Okay, so welcome everyone to the August meeting. Let me stop sharing this. I'll go to my meeting. Welcome to the astronomy section of the Rochester Academy of Science for the, I put and, this is last month's presentation modified. Instead of the, it's and. The August virtual meeting, so welcome. I want to first thank Dave Pesch's company Expudo for donating this service, the big blue button for us to use. The big advantage for us, instead of using other venues, is that or methods, is that we can use this for as long as we want, in each meeting, and host as many people as we like. There's no limits, and it's free to us. We don't have to pay for the service. For something like Zoom, we would have to pay for getting so many people on, or to broadcast beyond about an hour. So thanks to Dave, he's donated the service to us, and it's been it served us pretty well ever since April. All right, so how it's going to work, as with any meeting, if it gets noisy, I'm going to mute you. I'm not going to do anything with your mute now. If you happen to have a hot mic, you might find me turning you off, but you can always turn yourself back on. Right down below this presentation, where my dot is a microphone. If you press that microphone, it will turn your microphone on or off depending on where you are. Just right below that dot, you should find a microphone to turn yourself on and off. If you have a question during the talk, please chat. Use the chat function. There's a little just to the left of the presentation screen. You can chat in there, and I'm glad to enter or let the presenter know the question. And if I happen to mute anybody or everybody, I'll unmute you at the end of the presentation. But you could unmute yourself at any point in time if you need to. If you have a headset, it's best to use that. It's a lot easier to talk and to hear what's going on if you have a headset. All right, so welcome everyone. We'll do some announcements, and then our feature talk is by Matthew East, who's just confirmed that he's here. He's the lead Opto-Mechanical engineer of space structures for the Space and Airborne Systems at L3 Harris Technologies. That's a mouthful, but he's got a lot of insight on the decadal survey of what's going to happen for the next 10 years with NASA. And so the title of his talk is Future NASA Flagship Missions. We'll get to see what is in the works for the next 10 years and beyond. So that should be pretty interesting. All right. So first up, has there been anybody that's done observing they want to talk about recently? Well, I know that we all went out to the Ionia site, the Max and Marion Farish Center for Observational Astronomy on Saturday, July 18th. And those pictures you see there are from that event. We had about, I want to say, between 30 and 35 people. We had our masks. We were wearing them when we were talking to each other in groups, and we were taking them off when we were looking at our own scopes. I'm laughing because Bill Schlein just said nice house hat, Mark. So it looks like my hat is the cave roll off in the bottom right picture. Thanks, Bill. But we had a really good time. A bunch of folks brought their scopes, and you can see a few of them there. A borrowed scope. We had a roll off open. Somebody was using the big dome. I think we had a really good time. We had people there that we hadn't seen in a very long time, and so it was fun to see all those people. Let me ask you, if you would now, if you have a camera on, if you could turn it off. You could go down to the bottom. It's the third button from the left. Turn off your camera. I'll leave mine on so you can read my lips. Kenny, can you turn your camera off? Ken, can you turn your camera off, please? Ken Kressler. Let me see. Let me see what I can do here. Okay, I'm gonna move myself over here. Okay. All right, so we've had a couple of star parties. You guys seeing my picture in the middle of the screen here? Trying to move it. There we go. We've had 2 virtual star parties so far. I recorded the first one. I thought I recorded the second one, but I didn't. And we'll continue to do this. We're getting pretty good at picking objects, looking for them in the sky, taking short images of them, and then talking about what we're looking at. Generally had anywhere between 12 and 15 people for those events. So it's actually a lot of fun. We get some good questions and some good feedback. The problem we had, I'd like to do this live and extemporaneously, but the problem with that is our internet speed at the Ferris Center is terrible. It's I started to say before, it's rated at 1 meg. We might get up to 10, and that's not enough really to stream. Upload, that's download, but upload is actually less than a meg. So if I'm streaming, I need a little more bandwidth, or we all need a little more bandwidth of that. So I've actually put a call into Spectrum to see what it would cost, what it would take to get a higher speed internet out there, unless we want to wait for Elon Musk and his satellite system. We'll see what happens with that. Anybody have an idea when that's supposed to happen? Elon Musk and his system?
As soon as there's too many satellites to see the stars.
Yes. Yeah. Craig Kaplan, who was at the Tuesday Star Party, really enjoyed it. I had a lot of fun doing it, and I know that the people that were there had a lot of fun doing it. It's only an hour out of your time. I sincerely hope that people will try to make that. It's really a pretty good time going to the Star Party, and you don't even have to leave your couch. Valerie says it's happening now with Tesla. The tests have just begun, so can't happen too soon. As long as it's up there, we got to deal with it. So, all right. So I want to put thanks out there to the crew that came out last Saturday morning. There's a crew on the left. That's early in the morning. You can see the long shadows in the east of the crew walking into the right-hand side of that picture, coming into mow. Chris Pryor came in and worked with John Schultz and did a lot of the gardening in there. So the Max and Marion, the Marion and Max Farish Center for Observational Astronomy got a lot of work done. Roger brought his chainsaw, and you can see piles of stuff over here by the around the brew house. So I don't know how much further you got over there, Roger, but I know that was pretty crowded over there. Thanks for doing that. And it looks like Leo and Nick were out there mowing the lawn. So the Ferris Center is in prime shape. I want to give thanks to all that crew that went out there. We're still in mowing season. We still got a lot of weekends or days to mow. And as it rains and gets really hot out, it's going to grow faster. So can always use help mowing the lawn. But thanks to everyone that was out there. I know there's quite a crew out there last Sunday. All right, so coming up, we'll have a board meeting next Wednesday. We're starting it early. We're starting it at 6 to accommodate the Perseid meteor shower. So if it's clear, we'll stick around. We're not actually going to be meeting at the Ferris Center, but we can head out to the Ferris Center to have a shower watch or observing. For the board meeting, all members are welcome to attend. If you want to email me, let me know that you want to attend the meeting. I'll send you a link to the meeting. It has a link. It's actually the same link that you get here, but you need a password to get into the board of directors meeting. Just let me know you want to come. Glad to have you with us. And then after that meeting, the reason it's early is to watch the Perseid meteor shower. And here are the notes on the meteor shower. There's a lot of words here, but really this is the same rules that we had for our gathering on July 18th at the Ferris Center. We want to make sure that we obey the regulations that New York State has in place. So if you come, you need to sign in the education building. There'll be a clipboard and a sign-in sheet. Let us know you're here in case we need to trace contacts if somebody comes down with the the coronavirus. Please ensure there's 6-foot distance between you and other people. If you're going to be less than 6 feet apart from anybody, you must wear acceptable face coverings. The building, the woke building, the main building can have no more than 30 people in it. It's rated for 60, but they're only letting us have a maximum of 30 people in there. I don't think that should be an issue unless we have a really big turnout at the center. And then inside the 2 big observatories, the cave or the Wolk roll-off with the 20-inch Dobsonian in it, both of those, no more than 4 people in that building, in those buildings. Both of the bathrooms, the upstairs and downstairs, will be clean the day of the event, and they'll be available for use. The rules of those using those are that you wipe down the faucet handles with the disinfecting wipes that'll be there before and after use. Wipe the toilet seat if you use it or you handle it, and then dispose of any wipes in the trash can. Please don't flush them. We're on a septic system, and it's all it's going to do is clog things up. So there'll be trash cans in both bathrooms. Just dispose of them there. Then wash your hands. Because it'll be a star party, use red lights. There, if you don't have a red light, a red flashlight, there are about 7 or 8 of, maybe 10 of them now. I think there's a bunch more there in the library. Behind the door in the library are some red lights to use. And enjoy the company. Have a good time. It should be fun. If it's going to be clear, right now it doesn't look great. It looks like there's a possibility of rain, but you never know. If that's passing showers, it shouldn't be too bad if it's a thunder shower on and off, or it didn't look like a big chance of rain, but it looked like there was a chance. I put Tuesday night, but that's actually Wednesday night. I'm sorry. That's a Wednesday. I put Tuesday on there. Just know that that'll be Wednesday. I just noticed that. Excuse me. Coming up in September, our September meeting will be a week later. Not going to be the first Friday in September, allowing us time to do things after Labor Day. So Friday, September 11th, will be our September virtual meeting. And one of the things that's happened since we have excuse my dog, since we have this virtual setup for meetings, we're able to enlist people from outside a local circle. And David Bishop has done a good job of getting a hold of a former local guy, and Eric Mamajek, who's now works at JPL, and he's given us some of his contacts that are people that are willing and able and want to do talks around. And so for September, we have one of these people from JPL, John Callis. He's the manager of the NASA National Science Foundation Exoplanet Research Team. And he's going to give us a talk of the current state of all the Mars probes, including the latest on the Perseverance probe, which is the Mars 2020 probe you might have heard of. So that's Friday, September 11th, same time as this meeting. So that's our September meeting. And I know that we have another one of Eric's colleagues at JPL lined up for another talk. So looking forward to taking advantage of some of those JPL contacts we got now through Eric Mamajek. So it's not only what you know, it's who you know, right, Dave?
Sorry, muted. Yes,
all right.
who you know. It's
right.
amazing the people that you find online.
That's true.
As far as this particular talk goes, I'm a recent hire to L3Harris. And I was completely amazed to find out the stuff that's actually going on here in Rochester, New York.
Okay.
One of the things that I'd love to do, I don't know if it's possible, but I'd like to see if I can get you guys a tour of the facility. I know that they're given some. When I wanted a tour last year, I actually put my hand on the box with a mirror in it that's going to be put into the W1st Space Telescope.
Oh, that's cool.
Sitting right there on the factory floor. So, with that, I'll let you go.
All right. Well, that brings us to our feature presentation with Matthew East. I introduced him as our lead opto-mechanical engineer, space structures for the Space and Airborne Systems at L3Harris. Title of his talk is Future NASA Flagship Missions. So, Matthew, let me give you the presenter's controls here.
Thank you, Mark. Is my audio coming through well?
Your audio is perfect.
Wonderful. Well, thanks, Mark, and thank you to David Bishop for the introduction and inviting me to speak to you all. I've had a storied history learning all about space telescopes and what are the capabilities, what are we able to do, and what are we going to learn next? And it's been very exciting to work on these things. I started this career back in 2012 at MIT Lincoln Laboratory. From there, I moved on to the Kodak competitors in Danbury, where they actually made the Hubble Space Telescope. And now I'm here in Rochester at what used to be Kodak and is now L3 Harris, and still working on very exciting activities. What I'm going to talk about now is the future flagship missions that NASA has planned for the next decade and beyond. I'm curious, is anyone here on the call familiar with the NASA Great Observatories?
I don't know.
That's okay. So the NASA Great Observatories, I'll share a little bit. They include things like Hubble, Spitzer, Chandra, probably Herschel is on the list, I would think. And pretty much all of these historic groundbreaking missions have started with a recommendation made by the Decadal Survey, which is conducted by the Academies of Sciences, the national academies. And basically, they get the best and the brightest, all of academia and government and industry together, and they try to decide what should the country and the world invest in next in terms of space telescopes and astrophysics research conducted in space. And this time around, we're coming up on it's 2020 now, so it's time for the 2020 Decadal Survey, and it's time to recommend what comes next. And as part of that process, NASA has invested in 4 study teams to basically compete against each other. It's not a cutthroat competition; it's really a friendly gentleman's competition to develop the best concept for the next major flagship mission that's going to be recommended by the Decadal for investment. And there's also mid-size and small explorer missions that are being recommended and chosen from in the Decadal. But really, NASA has invested for 4 years in these 4 different activities with 4 different concepts that could become the next big space telescope. Other systems that have come as recommendations from the Decadal Survey include the James Webb, which may launch sometime soon. It was supposed to launch 10 years ago or so, but hopefully it keeps creeping up on us, and hopefully it's in the next few years. And W1st was mentioned earlier. That's being built here in Rochester. We have a big role in that. I should say that in this presentation, it'll probably be 20 minutes or so, unless folks ask questions. So I'll encourage anyone to interrupt me with questions or curiosities. So maybe you may have discussions beyond 20 or 30 minutes. I will say also, my views are my own and not necessarily the views of L3 Harris Corporation. And I'm not speaking on behalf of L3 Harris Corporation necessarily in this talk. So, hopefully it will reflect well on L3 Harris regardless. So I guess we'll get into it. Let's see if I can share the presentation here. And I'm going to take presenter role. And I'm going to try it this way, and you can let me know if it works or not. Go to full screen. So unfortunately, the final reports published by NASA are in PDF format as written documents. So they're in 8.5 by 11 type format that you can print out. Not ideal for a computer screen, but nonetheless, I think it's some of the most interesting reports I've seen in a long time. So I'm going to share a preview of the 4 different mission concepts that these 4 study teams came up with, and hopefully the final reports will speak for themselves. Is everyone able to see my screen and see a picture of HabEx?
Yes.
Wonderful. So there's 4 different missions that have been studied, and each study team trying to make their case, make the best argument that their mission is the best, and there's what we should be investing in the future. And the first one I'll discuss is HabEx, and it stands for Habitable Exoplanet Observatory. And the idea is we want to find Earths out there, planets that are very similar to Earth and may be habitable. And we want to find evidence that those planets can support life. And these are planets not in our solar system, but way out there orbiting other stars and other star systems a pretty good distance away. So this is a little bit about HabEx and what they're trying to do. They have 3 goals that they describe here. One is seeking out nearby worlds and exploring their habitability. And it sounds like very Star Trek language, seek out nearby worlds. But that's literally what HabEx is designed to do. It's also designed to map out nearby planetary systems and understand the diversity of different worlds or planets there. And all sorts of other new exploration for solar systems, galaxies, everything you can find in the ultraviolet through infrared wavelengths. HabEx, there's a little picture of it at the bottom. On the left, that's the telescope itself. It's a 4-meter off-axis unobstructed telescope. And basically a perfect circular pupil with no spider veins or secondary mirror in front of it that might limit contrast. And separated some tens of thousands of kilometers away is a star shade, very specialized designed star shade. And what that does is, if you've ever on a bright sunny day been trying to fly a remote aircraft or something like that, and trying to actually operate that thing, you might notice it flying by the sun at some point, and you have to put your hand up and blot out the sun so that you can actually see what you're looking at. Or same thing trying to go bird watching or something. This does the same thing. The star shade that's tens of thousands of kilometers away from the telescope, basically it doesn't blot out the sun, but it blots out another star, so that the telescope can thereby see the solar system or the system of planets and asteroids and what have you that is orbiting around a far distant star. And that's one of the methods that HabEx has to do that. But the trouble is that huge star shade that's tens of thousands of kilometers away, you can imagine, once HabEx takes a picture, series of data collection looking at one star, it wants to move on to another star and start looking at other things. And for the star shade to get where it needs to be perfectly aligned between the star and the telescope, it's going to move, you could imagine, thousands of kilometers. And that takes time. So what are we going to do in this time? Well, HabEx has room for guest observing programs and things like that, but it also has an internal coronagraph, which has different performance characteristics. But there's been talk of an internal coronagraph instrument, which could effectively block out the light from other stars without use of the star shade. And between the 2 methods, with and without the star shade, HabEx can collect more data on far away planets going around other stars. So this is another interesting one. This is very similar to HabEx. It's called LUVOIR, which stands for the Large Ultraviolet Optical Infrared Space Telescope. That's a mouthful, but it is worth it. This is very similar in terms of wavelengths that it's operating at, but there's a significant difference between HabEx and LUVOIR, and that's aperture. LUVOIR, there are two concepts proposed: an 8-meter aperture concept and a 15-meter concept. Both would be folded up in a spacecraft the same way James Webb is, and both would deploy and are compatible with multiple of these next generation launch vehicles. You hear about Elon Musk and SpaceX and Blue Origin and the NASA's SLS. They're coming up with all these bigger and better launch vehicles, which can carry more capacity, and that's why LUVOIR is looking at this 15-meter aperture, because it's possible now. It was not possible before. So what can you do with 15-meter aperture? That's a question that is a big part of what they're trying to figure out. And one thing, this image in the top left, it shows us with a 15-meter LUVOIR, what could you see if looking at a distant star system. I don't know how many parsecs or light years away the specific model represents, but they hypothesized, well, what if there was a mirror of our own solar system and it had the same planets, the same activity as our own solar system, the same color and brightness of star? What would it look like if we were looking at our own solar system from a distance of the stars that we're going to survey? And at that distance, this is what it would look like. You would actually have pixels resolving Jupiter and Venus and Earth. And the process is actually a direct imaging process. So you're actually taking a picture of planets orbiting around a star very far away. And you can see, there's information about the colors of the different planets there. You can see there's clearly a different color between Earth, Venus, and Jupiter. You can also, assume that there will be data in the infrared and ultraviolet beyond the visible, because it is a large UV optical IR surveyor. And in the top right, it shows that the larger aperture can collect more data and it can directly image more planets. So it's more effective and quicker at resolving these things than a smaller aperture. To understand a bit more about what aperture can do for you, the bottom left, you can see pictures by Hubble. There's a galaxy, a series of galaxy photos. The first on the far left is 2.4 meter space telescope, what you might see with Hubble. And the next two pictures show what you can do with LUVOIR with an 8 meter and a 15 meter. And you can see a lot more resolution and a lot less noise, a lot more signal in those next two pictures. But just because LUVOIR is so big and it's well suited for looking at things far away, that doesn't mean it's the only thing LUVOIR can do. LUVOIR can also monitor our local solar system, our neighborhood. The very bottom pictures on the far left, that's Pluto. That's the best picture Hubble was ever able to take of Pluto, followed by what that would look like with the 8 meter and 15 meter LUVOIR. And the way we're able to simulate that is because New Horizons just happened to fly by Pluto the other year. For the first time in history, we got close-up pictures of Pluto and what that looks like. With LUVOIR, we could just go and look at Pluto. At this point, New Horizons has flown by Pluto. It's never going to come back. It's never going to see Pluto up close again. And that's it. We're not going to see any pictures like this of Pluto for a long time, unless we make LUVOIR. LUVOIR can go any day of the week and go integrate for a few minutes or hours on Pluto and make flyby quality or approaching flyby quality images of Pluto and other objects in the solar system. So you can imagine, same thing like Cassini's survey of Saturn and the moons of Saturn. You could just do that whenever, pick a time. You don't have to wait years and years and years for a flyby mission to reach that object. You can just, do it on a whim. This page talks a bit more about LUVAR sensitivity. I can see 30th to 32nd magnitude objects in some cases. So really dim stuff that LUVAR is able to resolve with that huge aperture. And it just shows this curve here with wavelength versus limiting sensitivity. And it shows how much more sensitive the LUVAR would be compared to space telescopes. Here's James Webb and Hubble. And compared to ground telescopes, this is the European Extremely Large Telescope at 40 meters. And because LUVAR is above the atmosphere and avoids those effects, it gets so much better performance, even at 8 meters, than the 40-meter European ELT. So any questions on these UV optical infrared missions before I go on to the next two?
Matt, we had a question. Will the James Webb satellite not be able to do the same thing as LUVAR?
Absolutely not. So the James Webb satellite is tailored for a narrow field activities, which is similar to LUVAR. The James Webb is also tailored for infrared, and it looks pretty far into the infrared toward up to about 10 microns or so. So a lot of the light, almost all the light that James Webb is looking at is stuff that you can't see with your naked eye. LUVAR can see all the visible spectrum. Anything you can see with the naked eye, LUVAR can see that, and many orders of magnitude clearer and better and brighter. LUVAR also covers the ultraviolet, which James Webb does not. So you're going to see a lot of different things with LUVAR that you could not capture with James Webb.
Thank you.
Yes. Any other questions about LUVAR or HabEx?
Jeff Carr asks if will it be able to do spectral analysis of atmospheres?
Atmospheres, yes. So it will be able to do spectral analysis of atmospheres. It will be able to detect certain things, but not other things. I think oxygen, water vapor. I think methane, ethane are part of that list of things that LUVAR can detect. There's other things that I'm less familiar with that some of these other missions that we're about to get into can detect, which LUVAR can't access. So there's, LUVAR is not perfect. It cannot do everything. It can do a lot of things better than we've ever done before. But there's still other things that LUVAR, falls short of. And that's really in the far infrared and the X-ray, which is the next two telescopes we'll be talking about are operating in those ranges. All right, so if there's no other questions, we'll keep going. So the next one is operating in the X-ray. It's a successor to Chandra, or someone mentioned AXAF in the chat earlier. AXAF and Chandra are the same mission. And that was a mammoth X-ray telescope, much of which was built right here in Rochester. And, hopefully Lynx, Rochester will have an opportunity to be involved in this successor to that activity, Chandra. So Lynx is really quite a ambitious telescope in a number of ways, and it looks very different from the two we've just looked at. Lynx is targeting stellar evolution, galaxy evolution, the dawn of black holes. Lynx is really trying to find the history of the universe and observe things with greater resolution than's ever been observed before, and learn more about the different life cycle stages of galaxies and stars. And it can see more energetic things that these X-rays, they're the most energetic particles that anything in the cosmos gives off that we haven't been able to observe really in the EM spectrum. And it's going to see things that none of these other alternative missions can capture. Picture here showing the exquisite resolution of Lynx. In the very top, the center is Lynx. And in the top left, you can see the same field of stars imaged by Athena, which is an X-ray telescope I think the Europeans have recently commissioned, and James Webb, this very same field. And you can see, hopefully, if your screens are full screen, you can see very sharp pinpoint stars in Lynx, and very sharp pinpoint light sources that are nowhere near as sharp in these other missions, and that's the resolving capability of Lynx. So these are some pictures of hot gas that might be star forming regions, and pictures of what the UV optical can show you in that second column there and the first column, and on the far right what Lynx can show you in the X-ray domain, which you can see totally different things. And you may have seen pictures where it's stacked, and you can see a picture from the infrared from one telescope, and the UV and IR from UV and optical from Hubble, and the X-ray from Lynx. And all these different wavelengths can see different aspects of distant gases, distant galaxies, and distant star systems. So how does it do it? It's much like Chandra. It's a grazing incidence telescope. So the light is actually collected with grazing incidence optics. The reason we do that is if you're trying to use James Webb or trying to use Hubble to collect X-rays, you're going to have a problem. The same problem that I guess they solved by putting lead underwear on you when you go to the doctor to get an X-ray. If you don't have lead underwear, the X-rays are just going to go right through you. And same thing would happen to James Webb or Hubble. It would not be able to take the photons and guide them to the camera because the photons would not be collected. They'd just go straight through, and they'd keep going. So way to get around that is grazing incidence with these exotic, I think they're indium coatings, which can gather the light. And in the case of Chandra, on the left here, you have 4 shells. They're zero-door optics. I think they're coated with indium. And on the right here, you can see Lynx. Rather than 4 shells collecting the light, there's 457 shells. And you can see there's a larger aperture, and more shells, more mirrors, more aperture. That means more light, more resolving capability. And they claim that Lynx will have 50 times the throughput of Chandra with soft X-rays, and 1,000 times the survey speed. So, what Chandra could survey in 3 years, Lynx can survey in a day. So that's impressive. So the fourth and final interesting mission concept that NASA's study team has tried to develop is Origins. Origins Space Telescope is unique from the others in that it operates far into the infrared, even farther than James Webb, significantly farther. James Webb, I think, goes out to like 30 microns, maybe 50 microns. Origins goes out to 500 microns, so about 10 times the wavelength or more than James Webb. So there's a lot of different light in there that can be accessed. The way they started their mission development is they asked these fundamental questions that, what do we think we can address with this mission? And what they think they can tackle is, how does the universe work? How did we get here? How did life form? How does life exist? What history of solar system development and evolution led to habitability and liquid water being in a place, and all the other ingredients for life? which the far infrared origins can really access a lot of those other organic molecules, and they can see, here's evidence. You see all these organic molecules here. It's probably a pretty good candidate for somewhere where there might be life or might be able to sustain life. And they're trying to answer, are we alone? Can you, find life elsewhere, or some evidence that, life can be supported? So this just goes into a bit more detail on, how they do it. They look at, the development of metals being developed in stars, and how do they grow their central supermassive black holes over time, and the evolution of galaxies. They look at the, history, basically looking at many different solar systems or different star systems. And by surveying tons of them, they can find young ones, old ones, middle-aged ones, and they can see a continuum of how conditions for habitability develop in all those different solar systems around different types of stars. In particular, they want to look at M-dwarf stars and if they can support life with planets they observe there. They talk about carbon dioxide. That's one of the key signatures that they're looking for, but they can capture a whole bunch more than that in terms of atmospheric observations. And part of that is atmospheric, basically light reflected from a star that travels through a planet's atmosphere and then finds its way to the telescope. And some of it is light refracted through the atmosphere, and that's all information that they're able to look at the spectra, and they can tell, okay, oxygen is present, and it's not just O2, it's O3, there's ozone present as well. So that's the type of thing that they can see in the spectra when looking at planets around other stars. It's a 5.9 meter telescope, about the same size as James Webb, but very, very different. And the reason it's so different is the telescope temperature is 4.5 Kelvin. So that's very close to 0 Kelvin, absolute zero. I guess for reference, hot day in Rochester is maybe 305 or 310 Kelvin. Cold day in Rochester might be 260 Kelvin. 200 Kelvin, I don't think anywhere on the surface of the Earth can reach 200 Kelvin. 4.5 Kelvin is way down there. And the image planes, the sensors, are even colder than that. They're very close to absolute zero. I think they're tenths of a Kelvin. And the reason it's so cold is in the infrared, any temperature or heat shows up as background noise. So if there's a little bit of heat in, say, the primary mirror, it's going to radiate in the infrared, and it's that radiation coming off the telescope itself is going to blind the telescope and show up as noise. And by getting the whole thing so cold, it could be the same exact design as James Webb. In fact, folks have looked at that. But by getting it so cold, they can get the sensitivity way down. They can drive the noise down, and they can get a lot more signal and resolve a lot more detail in the far, far infrared beyond James Webb, beyond what WFIRST and RST can do.
I have a question for you, Matt.
Yes.
Several years ago, question from Mike Richmond. Several years ago, Origins was specified to be an 8 to 15 meter telescope. Did they run out of money?
That's a good question. So the NASA astrophysics director, I think Paul Hertz, he said, all you different mission studies, you're going to have to fit in a box. I think he said, none of you can cost more than 5 or 6 billion. And everyone was kind of scratching their heads. How do we do that? And it was like, well, you can do it this way. You can make it a little smaller. Librar, they said, well, we're really ambitious. We're going for 15 meters here. Do you want us to just scrap that? And they said, no, we're going to grant an exception for Librar. Librar can, stay at 15 meters and keep being ambitious. But Origins, the real differentiator is operating at cryogenic, 4 Kelvin type temperature, and it's not the aperture. So that doesn't really create the identity of the mission, the aperture. So they were able to sacrifice a bit to get to the 5 billion type dollar threshold.
I have another question on Origins. How is it being cooled? Is it different from how Spitzer was cooled? And to get as cold as it's going to be, it seems like it's going to be very different.
So I think it's very much the same concept as Spitzer. Basically, any sunlight or anything warm needs to be isolated, and you need a nice radiative link to the cold of space. And you also need active cooling with conductive, cooling through the system. You see on the top right picture, there's a number of shells, and basically the outer shells are sun shields, which the sunlight will be beating down on that side of the spacecraft, and they're going to reject most of the heat and reflect it back at the sun, and it's not going to get anywhere. But those things will heat up a bit. They might heat up quite a bit. And that's why the inner shield is there, because that's going to be maintained a little bit cooler actively. Part of this is passive. They use some very silvery multi-layered insulation to achieve just passive. You don't need any energy to cool things. And then at the very interior, that innermost shell and the telescope itself, there may be some active cooling. There's definitely active cooling in the telescope to drive things as cold as they need to be.
There's another question on this: is preliminary target selection part of the concept development?
Yes. So on either the next page or the page after, I have links to all of these final reports in full. Each one is hundreds of pages, and it includes all of that from what types of targets do they want to survey, how are they allocating observing time. They have different mission objectives, and they're going to spend different amounts of observing time on different things. And some of them, like HabEx notably, are going to have open observing time. So things that haven't even been thought of or identified yet that astronomers may want to observe in the future. You can call in from a university and you can submit your concept as something that you want to spend observing time on HabEx, and here's what you hope to achieve. Here's how many hours of observing time it'll take. They have a whole program for that too.
So I'm curious about the active cooling part of Origins. Is that different from Spitzer's, or pretty much the same system?
I think it's pretty much the same.
Roger McDonough asks, will any of these be serviceable or reachable by future astronauts?
So not only will they be serviceable, but they are required by law to be serviceable. An act of Congress was made several years ago that says that future space telescope missions of this class shall be serviceable. So unless taxpayers from a different country other than the United States are going to step in and make this happen, as long as the United States is doing it and they don't change the law requires that these missions will all have to be serviceable.
Very good.
Really interesting questions. Really interesting questions.
I got a bunch of people typing at the same time. We'll see who comes up here. A question says, what orbits are planned?
Oh, what orbits are planned? So Origins is at the Sun-Earth L2, and I think most of these are about the Sun-Earth L2. Same place as James Webb.
That's a good one.
So how big is that L2 area, huh? It sounds like it could get crowded out there.
I don't know. I guess in my mind's eye, it's a bit like Geo, where you're all going around the Earth and you're all kind of sitting out there going around a point, but you don't necessarily have to be close to each other because there's a certain radius around that exact point in space that all of them are floating around, and that radius is so many kilometers that, or thousands of kilometers, that no one's bumping into each other.
Mike Richmond got a great quote. It says, "Space is big, really big. You might think it's a long way to the chemist." Very good, Michael. Jeff Carr asks, "It sounds like these missions are competing for dollars. Can we get all 4?"
We get all 4. That's a great question. I think it's going to take some citizen science to get people out on the streets talking to taxpayers and getting people to send letters to Congress to get all 4. Unless someone on the call has I guess $20 billion or so. Speak up.
We're all checking our wallets right now. Nope. What is it likely that just one of these will be funded?
The vision is that just one. Yes, just one. For example, the last decadal, the recommendation for a flagship was W1st, which is now the Roman Space Telescope, named after Nancy Grace Roman. And the one before that was James Webb. The decadal before that was, so each decadal, the last 2, have just recommended one big flagship.
So Webb has gone through 2 decades of development at this point, huh?
Yes, it's dragged its heels. But I guess if you're doing something no one's ever done before, you should be given a little latitude.
So Mike Richmond said, "Should we vote here on which one ASRAS would prefer to see up in space?" What do you guys think? Write it in your chat. I could put a poll up, but I have to take it away from Matt to do that. So let's do it in the chat. Right, which one you'd like to see? We've got Habex, Louvoir, Lynx, and Origins.
Yes.
Jackie likes Louvoir. I kind of like Louvoir.
I'll give my answer after a few people have had a chance to answer.
Bill likes Origins. All right, I'm gonna start keeping score here. All right, Habex, Louvoir, Lynx, and Origins. Right now I've got 1, 2, 3. Dr. Richmond says Lynx, so Joel Castor won't be sad. He's a professor at RIT working on that stuff. So the French sounding one, that's Renoir. Valerie says whichever one can find the aliens first. Well, so far it's overwhelmingly Louvoir. I've got 9 Louvoir, 1 Lynx, 1 Origins.
Wow. So it's really hard for me to say this out loud because I've been lucky enough to support all of these NASA teams to one extent or another, and it kind of breaks my heart because I really do like all of them, but I also favor Louvoir because frankly, visible light. I can see visible light, and to think that if someone was close enough, they could see the things that Louvoir's taking a picture of. That's pretty dang cool. Also, aperture is king. The bigger is better when it comes to telescopes.
Dr. Richmond says, "Stupid optical zealots." We need people need to undergo visible light sensitivity training.
But I really do like all of these concepts, and there's something good for everyone in all of them.
So what is L3 Harris's involvement with Librar, if that's the one we decide to go with?
So I can tell you the information I know is publicly available. So it may not be as
That's
interesting as what I might be able to tell you. The role in each of these, we've been part of a CAN study, a collaborative agreement network study to study all four of these concepts. We've also been part of a study to look at the feasibility of Lynx with the 437 or so shells. Those shells for Lynx, just to give you a flavor of how many mirrors make up the primary mirror for each of these, Hubble is a monolith. There's just one mirror. Origins, there's 18 mirrors, different segments that make up the primary. Librar, the Librar A has 120 mirrors. Lynx, hold on to your seatbelts. Lynx has about 40,000 primary mirror segments, all about 4 inches by 4 inches. 40,000. So that's a huge manufacturability question. And we tried to help address how would anyone go about doing that. We've been basically supporting as consultants on each of these, and I'm really lucky that I've been able to be a part of that. Now, of course, L3 Harris also has contracts for working on W1st or now RST. That is really exciting work, and I'm lucky I got to work on that. And LISA as well. LISA is basically LIGO, the laser interferometer that basically detected gravity waves for the first time, and everyone said, "Oh, Einstein was right. Gravity waves are things, and they travel, and they come from places, and you can detect them." And LIGO did that, I don't know, a decade ago, and everyone was very excited, and it was able to pinpoint where it came from. Everyone pointed their telescopes there and said, "Hey, there's a neutron star colliding with a black hole or another neutron star." And they said, "Wow, something actually happened, and this gravity wave actually found it." So basically, LIGO does that with a couple kilometer channels underground. LISA would do the same thing in space with spacecraft rather than a couple kilometers apart. I think hundreds of millions of miles apart, and literally a triangle of 3 telescopes all looking at each other, measuring distance, so that if the distances between them, the telescopes change by I think it's a millionth of a millionth of a millionth of a percent in distance change because of gravity waves. It has the sensitivity to detect that. That's something else. L3 Harris in Rochester is working on the engineering unit telescope for that right now. So very cool projects.
Bill asks, what's the time frame for selection of which of these is to happen?
So that's really interesting because it's very exciting that it's happening now. It took them 4 years for these study teams to come up with these reports. They had midterm reports, they had all these meetings, and now they have these final reports that came out last year, last August, actually, right on the dot last year. And the decadal survey, they also took white papers from basically open to everyone. Anyone could submit something about their thoughts on the state of the industry, what type of astrophysics breakthroughs are possible, what can new technology do for astrophysics. Basically, where are the big technology breakthroughs, and which missions are they going to help, and things like that. They basically had a call for inputs from all of industry and all of academia and government. And that call closed maybe 8 months ago, and they got all the inputs. And basically, they've taken their committee and gone into closed door sessions. And they're in closed door sessions until I think January or February of 2021. And at that point, they should be releasing the report for the decadal survey. So everything is mostly behind closed doors now, and we'll find out in 6 months or so.
Mike Richmond typed, "Uh-oh," from the news desk. A bill released by the U.S. House of Representatives July 7th would keep NASA funding flat next year at $22.629 billion. This move is a significant departure from the White House's 2021 federal budget request, which allocated $25.246 billion for the space agency for the coming fiscal year. So that's about $3 billion shy of where, well, $2.5 billion shy of where it was
Yeah.
projected.
And NASA's budget is spread across so many things as it is, between, Explorer missions, like probes. You were talking about, things going to Mars. They're spending money on a lot of different things. So, if a little bit can make a big impact and make a lot of science go away.
Yeah, Jeff Carr says off shelf versus advancing technology impact on decision.
Yeah, I think they want everything to be. They say, how ready is the technology, and they have this technology readiness level from 1 to 9. 9 is basically it's prime time. We've been doing it for a long time, and technology works, and it's all good. And 1 is like, it's a concept. Someone thought of it, and they wrote it on a napkin. And there's different levels of readiness all in between. And they want everything above TRL 6, which means it's been demonstrated in relevant environments, I think. So they want technologies that are ready for prime time, more or less, with some evidence that the things are going to work on these telescopes. They don't want things that are perfect. They don't want everything to have been done before, because the point of this is to do something new and spectacular that hasn't been done before. The biggest problem with technology is if you have a bunch of new technologies, like say you have 10 new technologies on a mission like this, say James Webb, not only are the new technologies, you got to figure out how they work, you also have to figure out how they interact with each other together. So there's other complexities that, you don't just have 10 new problems to solve. You've got, however many interactions there are between those new things. And that's part of the reason for the delays and the cost overruns for James Webb, is there's so many new things interacting with each other. So they want things that are new, but not too new, because, that will really be a big risk that the mission might fail.
Bill asks, is there any likelihood of multi-country funding?
Well, I guess for the case of LISA, that is actually led by the European Space Agency, and NASA is just supporting, and us in Rochester, we're just supporting the telescope aspect and a few other aspects. So there's definite collaboration now with the LISA mission. I think with some of these, I would expect absolutely there already has been. I mean, a lot of the meetings for the NASA study teams. It's not just NASA. There's folks from France, folks from Italy, all contributing to the development of these new missions already. So I have a feeling they will be partners in the future too. Contributing their brain power and maybe contributing some dollars as well. Definitely.
David asks, would there be any chance of a talk on the LISA mission and maybe a few of the other current ones that L3 Harris is doing?
I think that would be possible. I don't see why not. Luckily for this, I was able to find published material, which is already in the open. There have been a lot of papers out there, so I'd recommend searching papers from the SPIE Society of Optics and Photonics, and they've got all sorts of papers on these things for easy reading. But yes, I think we could put something like that together. I think so.
That could be pretty interesting, especially since it's all happening right here. A lot of it's happening right here in Rochester with L3 Harris.
Yes.
Any other questions?
Well, I'm
Matthew,
really
go ahead.
You're welcome. I'm really glad there have been so many questions so far. I guess I'll flash these references if anyone wants to take a screen capture and see the full documents. I'll wrap it up in the next 30 seconds. Also, just for curiosity, I'm working on some stuff at home. This is a 15-inch unobstructed telescope, and bottom there is a picture of polishing the primary mirror, which is a lightweight closed back, and there's some structures and kinematic stuff being built up top. Here's some pictures from the Great American Solar Eclipse last year, or a couple years ago, actually, 3 years, I guess. I thought I was doing a good job. This was with a telescope I made, but then my dad showed me the picture he took, and I decided maybe I didn't do such a good job.
Wow.
This one was by my dad. We were at the same observing site too, so I had no excuses. He had the same cloud coverage and everything as I was dealing with. So
that's spectacular, getting the composite of the moon in there as well. That's cool.
Yeah, the reflected light from the Earth hitting back on the near side of the moon. That's something. Anyway, that's all I've got.
Bill asked if you could show the references again. And Bill, I made copies of the links. When I send out the recording of this, I will put the links in the reference to the recorded version of this meeting. So it'll be out there in the email link for everybody. But here it is again. If you want to,
just want to get started.
If you want to take a screenshot, I actually will. I also took them live as Dr. Richmond was posting them up, and I copied them into another window, and I will copy them onto the invite to watch the recording of this.
Yeah, screenshots at my point will only take a picture of my screen.
Right.
This is all on the web,
Right.
So
this is all on the web, and if you got a picture of it, so you have to type it all in. I'll send you the actual links.
I just took a picture. That's all. My smartphone. It's good.
Okay.
Yeah, so hopefully everyone has plenty of reading material. These are 300 pages a piece or so. So
Bill wants you to explain the use of the Weber grill in your mirror construction.
Oh, the Weber grill. That's
Can you back up and show that again? There it is.
I actually have a mandrel in there, and I actually heat it up, slump the glass to the shape of the mandrel, and voila, presto, I get a perfect optical surface just from cooking some charcoal. It takes thousands of degrees to melt glass, and no, that's just there for burgers and dogs.
Gotcha. So that looks like celled glass. How thick is that glass?
It's a pretty thick one. It's almost 3 inches thick by a little over 15-inch diameter.
And what's the focal ratio you hope to get to?
So this one is f8.5 or so. So it's not too fast, but it's folded as part of an unobstructed telescope design. There's 2 other mirrors I polished and a fold flat. So it's a 4-mirror telescope, and together they make something a little bit faster coming out of the eyepiece.
Pretty cool. So do you grind by hand, or do you use any mechanical help for that?
No, it was all ground and polished by hand.
That's pretty admirable.
You can see a little help here. I get a bunch of rubber bands holding the thing up. I found out that polishing it, that little cell pattern from the lightweight mirror really prints through, and really there was no way to get rid of it. Tried filling it with water, sand, just kept coming. So it's held up by a bunch of little rubber bands, and I found out that actually reduced that effect on the mirror surface, which is, it also made it easier to push this 15-pound chunk of glass around for hours on end, lifting up some of the weight.
So that kind of suspends it over your lap there, and you're just pushing it around.
Yes.
Wow. That's That's admirable. I've always thought about making my own scope, but I don't think I had the patience.
We'll
How
see if
long
it
will
works.
I'm gonna say, how long will it take you to grind that mirror?
Oh, it probably took me 100 hours to grind and polish it.
Wow. And you've made other mirrors in the past?
A few. The eclipse photos that I showed you, I took. They were all that light was collected by a 8-inch optic I polished and ground.
Very cool.
Yeah, a lot of work.
We might have you back just to talk about your amateur telescope making.
Yeah, sure thing. I guess first thing I got to make this thing work.
That's true. Very cool.
But happy to share anytime.
Pete Bono asked if that was a blank weight, what the blank weight was.
If this thing was a solid chunk of glass and it wasn't a lightweight sandwich structure, I think it would be like 42 or 43 pounds. But since it's a lightweight sandwich, it's more like 14 or 15.
Nice. That's light. So you're going to have that telescope done for the next eclipse?
Yes, that's the hope.
Okay.
Maybe I can outdo my dad next time. We'll see.
Right. Off subject, but where do you plan to watch the next eclipse from?
That's a good question. It would be nice to do it from my backyard, but the challenge with Rochester is the probability of cloud coverage is much higher than some other places on the path. I really don't know where I'm going to go. But the benefit is you can just set it up and do all run through the clockwork and see and make sure you're tracking the sun the day before and stuff like that without worrying about setup and tear down
Sure.
and polar alignment and yada yada yada.
Yeah. Well, Rochester is very unreliable for weather. The week of April 8th, which would be the when we're going to have it here, we had every weather imaginable. We had beautiful, sunny, cloudless day. We had a cold, cloudy day. We had snow, and we had rain. So you don't know. We had all that weather in the same week in April, that week of April 8th this year. Let's hope it's not that way in 2024.
And it kept snowing in May. I don't know what that was. Winter in May.
Besides exoplanet observations, would LUVOIR be used to detect seasonal variations of our neighboring planets?
I think LUVOIR could see all sorts of stuff. They definitely plan to use it on neighboring planets and neighboring moons in particular. I heard they had plans to check out like Enceladus and stuff like that, and
Europa.
Europa for sure, and they'd be able to do all that, and they plan to do all of that. I don't know how much I don't know what they're going to learn, and I don't think they know what they're going to learn yet either. But they can certainly do much longer sustained observations of objects that you can't really sustain during a flyby type mission.
It's true. Are there any other questions for Matt? Well, Matt, I want to thank you very much for sharing the presentation with us and some of your hobby as well. That's fantastic. Thanks so much.
You're very welcome anytime, and thank you all for really good questions.
All right. Well, that's our meeting for tonight. We have virtual clapping going on. I'll clap out loud. Thank you so much. That was very informative. It was very interesting. So thanks for coming. We would love to hear more from you when we hear more of what's going on at L3 Harris with this. If you're interested in coming back to do a talk of what's happening at Harris, what you can share. and certainly when you get near with your scope construction too. So that'll be fun.
Wonderful. I'll be glad to take you up on that someday.
Awesome. Thanks very much, Matt. All right, with that, if anybody wants to stick around and chat, glad to. You could turn on your camera and slow everybody down if you want to see everybody. Thanks for coming, everyone. I'll put my camera on. Thanks, Matt.
Thank you again.
So who's planning on going to the Perseid meteor shower next week? If we have a basic or a decent night. Certainly got to be clear to do it. So I'm going to plan on going out to the site if it's going to be clear on Wednesday night next week. We did have, for those of you that didn't come out to the Saturday gathering on July 18th, we did have about 30 to 35 people there, and it was a lot of fun. Even though we kept our distance from each other, it was an awful lot of fun being able to see people we haven't seen in so long and socialize, keeping our distance. It was a lot of fun. We had at least 4 people brought telescopes and did some observing, and I know that one of the 3 of the buildings were being used. So we were able to do a little observing. Jeff Carr's a big maybe. Yeah, I would expect that with a meteor shower, they'll probably not see as many telescopes being set up, because you're looking pretty much big sky to try to see meteors. And if you're looking at deep sky objects or any kind of objects in the sky, you're not going to generally see meteors. So it's a much more social event, meteor shower versus a star party. All right. So I'm gonna invited a couple of people who are interested in the big dome. You may have seen some information on that next Friday. If you're interested in learning how to use the big dome, if you have a key, you need a key to get into the big dome. So you got to request one from Bob McGovern, who I don't think is on tonight, but certainly can show you without a key how to use the open up the building, get the scope set up, and if you want to. Right now we're set up for wide field imaging. We could also do narrow field F11 vision imaging, which we'll probably set up within the next month or so to accommodate looking at the planets. Since Jupiter and Saturn are in prime view, it's best to look at them through a longer focal length. We get a lot better detail using a longer focal length on those planets. And I think Bob McGovern's also going to get the Tinsley building, which has a very long focal length telescope. I believe that Tinsley scope is like an F17 or 19 or something like that. It's a real long focal length. It's perfect for planets. So he's going to get the Tinsley telescope up and running for us as well. So there'll be a lot of ways to look at the planets. This is the end of the summer, early fall. All right. Anybody have anything else they want to talk about? I'm sorry I didn't make wings for everybody, or I got plenty of beer here though. It's out. It's in the fridge right over there. Right over there. So or Pepsi. Or Dave has his raspberry lemonade or like raspberry iced tea.
Come on, you can admit drinking Coke.
I worked for so many years at Pepsi. It's a Pepsi.
I know.
I'm a Pepsi guy.
You see the commercial? There's a commercial with the Pepsi and the Coke guy.
Yes. It was just like that too.
I knew you were at Pepsi, and that's why I mentioned that. So
I appreciate that. I can't tell you how many times I've seen the cartoon, or somebody sent me the cartoon of the guy being called into the Pepsi manager's office, testing positive for Coke. Yeah. And Jeff, the beauty of virtual beer is there are no calories in virtual beer. See what Bill's going to say here. He's typing. I don't have a virtual hat on in this screen. All right, I have a question for you. How many people are wearing an astronomy shirt of some kind right now? I see Ken's got his ASRAS shirt on. I've got my Black Forest Star Party shirt on. Roger's got dark skies. They look like it cleared up, Roger. That looks like clear skies. Clouds on the horizon. Or are those clouds above you? Like hard to tell. Bill says he's neutral. RC Cola. Shirt. Who needs shirts?
Some clouds.
Some clouds. You see what it's like behind me.
High clouds. There's not much.
I got high clouds here too.
Are you cloudy up there where you are?
By me?
Are you cloudy in your area?
It's no, just some high clouds.
Okay.
Lots of high
Bill
clouds.
Gilman says, my shirt says Mesa Verde, different kind of science. Yes. Buddy Guy t-shirt. He may be an amateur astronomer, but he's a professional musician.
Buzz Reacher says Buddy Guy t-shirt. Maybe he's an amateur astronomer.
Could be. Could be.
Good grief. I don't have it. Every time I just try to move my my phone, and for some reason it just can't change in place. This new computers to have the touch screen so sensitive to pick up my just a little bit of a touch, it picks up somewhere else. I just got lost. I gotta fix something.
Bob Easterly says he'll bring beer Wednesday. Many calories. Yes. Bob doesn't bring low calorie beer. He brings good tasting beer. Jackie has a glow in the dark Devil's Tower t-shirt.
I don't see her.
Won't that destroy your night vision?
Shy, maybe.
What? Beer?
No, glow in the dark T-shirt.
Well, they don't glow that brightly. It's like having a red light. Bill says it makes you want mashed potatoes. So build a tower out of those mashed potatoes, Bill.
That's good.
Build it in your living room.
Oh, I don't have any table for me to put my laptop. This dining room's a little bit mess. I gotta clean it up for my wife. She wants to.
Jackie asked a trivia question. How tall is Devil's Tower? That's a good question. I don't know. But I will promote, if you go to the planetarium and see the movie National Park Adventure, part of the movie is some people climbing up in between those big igneous intrusions coming up Devil's Tower. It's kind of cool. So it's pretty tall.
Ocean count your tank.
It's got to be 1,000 feet, isn't it? What do you think? What is it, Jackie? Bill Gilman says 386 meters. That's the advantage of having a computer at your hand. So it is over 1,000 feet. It's an amazing sight, I would imagine. Yeah, I highly recommend seeing National Park Adventure if you got nothing better. I don't know how often it's playing that at the
Wikipedia says 1,267 feet above the Belfourche River, standing 867 feet from summit to base. The summit
That's
is
big.
5,112 feet elevation.
Pretty cool to see. Just tower emerging out of the middle of the landscape. The rest of the volcano eroded away. Just the interior of it.
That was the plug in the actual vent.
Oh yeah, yeah. That's exactly what it was. That was the lava stuck up inside the volcano.
Yeah.
Jackie says that it's on the Netflix too. So if you want to see National Parks Adventure, it's on Netflix. It is pretty cool in the dome in the planetarium, but if it's on Netflix, I recommend it. It's a pretty good documentary. It's about 40 minutes, 42 minutes long.
That's all I got.
Yep. Jackie says the oldest person to climb the tower was 87 years old. That's not an easy climb.
Oldest person to climb the tower was 87 years old. Holy Toledo.
And the youngest were a boy and girl, 6 and 7. That's crazy. So it may not be as hard as I think it is. I saw people using carabiners and rappelling tools, and kind of interesting. All right. Well, if that's it, I'm glad to see everybody. Those I'm able to see. Glad to see we had a bunch of people here tonight. I look forward to seeing some of you perhaps at the observing on the 12th. That's Wednesday next week, to perhaps catch some meteors. If not, maybe a beer taste or something. Thanks for coming, everyone.
Thanks.
No, Jackie says bye. Bill says thanks. All right. Take care, everyone. I'm going to end the meeting. Be good. Have fun.